Okay, let's take a look at one of the questions from the test reviews. The number might be different depending on the assignment you're working on, so we won't give it a number. We'll just call it the hot air balloon problem. You will know it when you see it, and if you've come looking for it, then definitely you know what you're looking for. The question says, a hot air balloon rises vertically from the ground so that its height after t seconds is given by the following function. And they give us the following function. H equals 1/2 t squared plus 1/2 t. They give us some extra information there where they say where 0 is less than or equal to t is less than or equal to 60. That's just saying that that function works in the first minute that the balloon gets off the ground. That things might change, it might rise at a different speed after a minute, but this works within the first minute. And lucky for us, they're giving us a time that's within the first minute. So you really don't need to worry about that. But if you're wondering why it's there, what it means, that's what it means. This is good for the first minute after the balloon launches. So what are the parts of this function so that we know what we're dealing with? Well, they're telling us h is the height of the balloon, and t is time in seconds. So we've got the height and the time. If we want to figure out the height of the balloon, we just need to plug in a time between 0 and 60 seconds, and this is going to spit that height out. So what does question A ask us? It says, what is the height of the balloon at the end of 37 seconds? Well, we just said the height of the balloon comes from plugging time into this original equation. So we want height after 37 seconds. Your time might be a little bit different, but the process is still the same. So if they want height after 37 seconds, we just plug right into this equation. You don't have to find a derivative. They're not asking for any kind of rate of change. They're just asking for the height, and that's the function they gave us. So we'll go ahead and plug it in. And then we have height equals 1/2 times 37 squared plus 1/2 times 37. Now, if you plug that into your calculator, or you are really good at multiplying fractions and doing big squares in your head, you will find that the correct answer here is going to be 703. So all we did was take the 37 that they gave us and plug it back into the original function. So what's question B asking us? Question B says, what's the average velocity of the balloon between t equals 0 and t equals 37? So we need an average velocity. I'll just abbreviate that. And that's between t equals 0 and t equals 37. So from the average velocity from the time it launches until 37 seconds. And you're going to say to me, Michaela, do I do a derivative? No, you don't do a derivative yet. They're only asking for the average velocity. They were asking for the velocity at a specific point in time, then we'd need the derivative. But for the average, we have to do what we did, I think it was on question 4 of homework 4, where we took the first time, and in this case it's t, so we'll call this t1. And we took the second time, and we'll call it t2 before we did x1s and x2s, but it's the same idea. And the formula for this now is going to be t2, or h of t2, there we go, h of t2 minus h of t1 all over t2 minus t1, okay? So we're taking the function, the original function, this guy up here, when we plug in this value, subtracting the original function when we plug in that value, and then subtracting the two values from each other. Well, it just so happens we know exactly what h of t2 is because we have 37 as our time, and we did h of 37 before. So that's going to be 703. Then I got good news for you. H of t1, t is 0. What happens when we plug in zeros up into our original function? Well, anything times 0 is 0, plus anything times 0 is 0. 0 plus 0 is 0. This is starting to look like the kind of math I can do in my head. And then finally, we just need to subtract t2 from t1. So plug in t2, that's 37. t1 minus 0, that's going to be 703 over 37. And if you plug this one into your handy-dandy calculator, your answer is going to be 19. So it's 19 feet per second. So for average velocity, you always want to do the second number and the first number, so label them, the function of the second number minus the function of the first number, and then put that all over the second number minus the first number, and that's going to give you your answer. And so finally, for part C, they want us to give the instantaneous, not instantaneous, they're just asking for the velocity of the balloon at the end of 37 seconds. And velocity in this case is going to be the derivative. They're asking for it at a very specific point in time, so we're going to give it to them. You can still, I think, I'm looking at my camera here, you can still see the main function up at the top. We just need to take the derivative of that. So we want h prime, and that equals, well, let's see, we've got the power of 2 up here, so we need to multiply, bring our exponent down. 2 times 1/2 is 2 halves, which is 1. So that's just 1 times t, and then we need to lower our exponent. So we've got this exponent up here, it's a 2, and I wrote a 2. We need to change that to a 1. So 1t to the first minus, plus, I should pay attention, plus 1/2. Because there was nothing to multiply by. There's kind of that imaginary 1 up there, and the t goes away. So our actual derivative here, if I do it without any typos this time, is just going to be t plus 1/2. What's our time? They gave us 37. 37 plus 1/2. You could write 37 plus 1/2, or you could just do, 37.5. And that's going to be your answer for that. So run through the steps one more time. For part A, all you do is plug in the time they gave you into the original function, and you're going to get an answer. For part B, you break it up into time 1 and time 2. Do the original function at time 2 minus the original function at time 1, all over time 2 minus time 1. We luck out because time 1 gives us both 0 for the function and 0 for the actual number. So we end up with 703 over 37, do the division, and we get 19. And for part C, all we have to do is take the derivative, which turns out to be fairly simple, a little bit of multiplying fractions, but no big deal, and it gives us 37.5. And that is how you handle the hot air balloon question.